Okay, you guys can be lazy. I'm going to try to read it, and you guys just need to be thinking, okay? So let's read our context right here. Zhu Wenjun? Am I saying that right? Anybody correct me? Zhu Wenjun? No? Is an ecologist who studies the change in the tiger population of Siberia over time. The relationship between the time elapsed T is in years, since Zhu Wenjun started studying the population, and the number of tigers is N of T. Okay, so this is the variable. The N is the variable that's dependent upon what the T is. That's why it's written like this. Is modeled by the following function. So here's our function. All right, here's our variable that depends on this variable, and this variable is what gives us the answer here. Okay, so complete the following sentence about the rate of change in your tiger population. In the tiger population, the number of tigers decays by a factor of 4/5 every whatever years. Now this is weird. 4/5. Isn't that weird? Because I don't see that in here. I don't see that in here. You said we could simplify the 16/15. That's actually what I thought the first time I saw this, and then I thought about it. Well, what can I divide the top and the bottom by? No, nothing. That one doesn't work. Okay, but you're like, no, but this you can totally get a 4 and a 5 out of this. I know you can, but how? It's not a regular simplification problem.
Pull out the square.
Pull out the square.
Yeah, the 1/2.
Yeah, okay, we can pull out the square. I understand what you're saying, but I'm going to make it a little bit more official, okay? If you have this 16/25, how can we make this into a 4/5? And I think you guys are thinking this, okay? I think you're thinking this. Because if we raise this to the 1/2 power, do you guys know what 1/2 power is the same as? What's the same as?
A square root.
It's a square root. Okay, so can we do that? Can we take the square root of 16 and the square root of 25, and would we get that?
Yes.
Yeah, okay, that's what this power means, right? And so I think the question right here is, when does this factor right here, because right now this is the factor, right? This is the decaying factor. But when is the decaying factor going to be 4/5? And the T is the one that changes, the 16/15. So what is T to get 4/5?
Oh my God, is it a 4?
It's 1/2.
Yeah.
So the number of tigers decays by a factor of 4/5 every how many years?
Half a year.
Half a year. That's your answer. It's 1/2 a year.
Oh.
That's it. Yeah, that wasn't a lot of math work, but it was a lot of thinking. Okay, we had to think a little bit on that one.
This is like geometry.
It felt like geometry to you?
Yeah, because you know how you have to like look at the circle and like there's no like specific formula.
Right. There's no specific formula. I think that's why it's called manipulation.
It sucks.
Because you have to be able to manipulate what's going on here to find out what does T have to be so that this is the factor we're multiplying to 650.